So I'm gonna show y'all how to solve a hard problem from Leetcode.com called trapping rainwater. And here's how the problem goes. Given n non-negative integers representing an elevation map where the width of each bar is equal to 1, compute how much water it can trap after raining. And then here they give a picture showing water trapped inside of these black, basically elevation, parts of the elevation map. Each one represents one unit, these squares. And so that's represented in code by this height array, or array called height, where here's 0, that's 0. Here's 1 block, so that's 1. 0, so that's 0. It has water in it though. And then 2, because that has height 2. And then 1 because that height 1, and 0 again, and then 1 again. So you can get the picture from basically how this map is showed here. And it basically wants you to determine how these blue things get filled in, the water. And this water gets trapped based on having a right edge and a left edge that can trap the water in here. And how can you do that? And as you can see, the answer to this output is 6, because you have 6 waters that can fill up this elevation map. So how can you do this problem? The intuition might not come. This is a hard problem, and that's probably why it's hard, because it's something that it's pretty hard to figure out on your own how to do it optimally. But I've done this before, so y'all gonna reap the benefits of that. And how you do this problem most optimally, or one of the ways you do it optimally, is to use 2 pointers, one at the start and another pointer at the end, and then move the pointers toward each other. Along the way, you want to keep track of the highest elevation that you've seen in the front and the highest elevation you've seen in the back. And as you're traversing this with 2 pointers from left and right, you want to keep track every time you get to a elevation that's lower than the previous height you've seen, that's a water spot. And then, so if I get here, or I get here where it's 0, but the highest elevation I've seen before that is 2, then I subtract 2 from 0, or subtract 0 from 2, and I get 2 waters, and I add that to my answer. And then by the time I move both the pointers, I've added all my water up into my result. And why do you want to use 2 pointers on the left and the right? Because you need to use the lowest value height pointer every time you do something, or every time you step through the iteration of what you're looking at first. Like here, I would start with this pointer because I know that there's a wall on the other side. You can't add any water unless you know that on the other side there's some height that will stop the water eventually. And so you need to always process the lower side first rather than the higher side. And this will make more sense when I jump into the code, hopefully. So I'm going to go ahead and jump into the code. So this is the problem statement again. This is a function called trap that I filled out already. And I'm just going to talk through this for the sake of time. And I'm using JavaScript to do this problem, or that I use to do this problem. And so how you want to start this off is that you have your height getting passed in. That's your height array. You want to start off with your water set to 0. This is going to be the answer that we end with. And then, like I said, you want to have a index that you want to have 2 pointers. So I'm going to call them front and back index. The first pointer is going to be at the start of the array, the height array, and the last pointer, or the back index, is going to be at the end. And then, like I said, I need to keep track of front max and back max. So I'm going to keep track of front max and back max by setting them to 0 to start with. Then, while front index is less than back index, so this is gonna keep my loop going as I move the pointers toward each other. I'm gonna pull out the value of front height and back height by looking at the height array and pulling out the value at the front and back indexes. And so here's where things get a little interesting as far as this piece of code. I want to do it while front height is less than back height, or I want to do this whole section of code while back height is equal to or less than front height. And so the reason I want to do that is I want to always process first the lowest height, either the front or the back. I want to process the lowest one first because I know on the other side there's a wall to trap my value because it's higher than the current value I'm on. And so that's how I know I can say that there's water in this spot. So it's a trick to the problem that if you don't do, can really mess the problem up pretty bad. If front height is less than back height, then if front height is greater than front max, like I said, I need to keep track of my max as I traverse through this elevation map. Then I just want to set the new front max to the front height. This is how I'm updating my highest max that I've ever seen on the front side. Else, if the front height is lower than my front max, then I know I got a water spot. So what I want to do is add to my water. The difference, like I said earlier, is subtracting front max or subtracting front height from front max. And that gives me my new water value. Then I want to move the pointer along forward so that I can go back in the start of this loop and go to the next thing. I can see which one of these is higher and I can start my next iteration. And so if back height is lower or equal to, then I want to do the same exact thing that I did on the front height and front max to the back height and the back max. So like I said in the front stuff, I said front height is greater than back max or front max. Here I want to say if back height is greater than back max, then update my back max, of course, to the back height. And then else I want to populate my water with the difference. And then here I'm going to actually decrement back index because I'm moving the pointer from the right to left there. And so by doing this, by the time I get to the end, I've populated my water with all the water spots I've seen from the front and the back. And I've made sure that I'm doing this in the proper order because I'm always checking if front height is less than back height. So I hope that makes sense. This is a hard problem on Leetcode for a reason because it's not one that you can easily get to with intuition. But after you do this problem and understand it, it does become easier. So run through this on Leetcode. Let me know what you think. Let me know if you know a more optimal way to do this. And I think I'm going to run it and let y'all see that it works. Works fine. And I submitted this earlier today, and it actually beats 80% and 86% on runtime and memory. Big O, or not, it's not big O, but just runtime. It beat 80% and memory it beat 86%, which is pretty good. And then let me go back for one more thing. And then we're just gonna talk about the big O notation, the time complexity. Since if I look at height, the length of height here, and I call that n, the only thing I'm doing here that is in reference to my height is I'm looping through. Basically, I'm checking every single thing in height one time, either from the front pointer or the back pointer. So that's just n. That's n operations that I'm doing as it relates to the size of my input. So my algorithm will scale at a big O notation of big O of n, which is basically linear. And then my space complexity, I'm not using any data structure or space that is filling up with the size of my input that like correlates with my input. All of these are constant operations because no matter how big my input is, these operations will always be the same. Or sorry, the storage will always be the same. I will never, because these always wipe themselves out every time I loop through. And so I'm only using constant storage or constant space complexity. So it's big O of 1 or constant. So that's it. Let me know what you think. And I appreciate you guys checking out the video. Let me know what you want to see in the future. Like and subscribe to the channel for more content like this. Thanks.